Good morning to everyone. My name is Ramesh, Assistant Professor, Department of Commerce and Management, Soundarya Institute of Management and Science. Now I am going to explain Bangalore University BBA Aviation Management course, second semester, Mathematics for Managers 2. Here, previous video I explained about Introduction to Operation Research. In that, one of the model is linear programming model. Here in this one, second semester BBA Aviation Mathematics for Management 2. Then unit number 1, Introduction to Operation Research. Here I am going to explain linear programming model. This one of the model of operation research. It is also mathematical model. Here we are going to study what is linear programming, what are the types, how we are going to solve, and then formulation of linear programming problem we'll say in different simple format LPP, and then graphical method, what are the advantages of linear programming problem, what are the limitations of linear programming problem. Now we are going to study what is the definitions and meaning of LPP, linear programming problem. Linear programming is a technique to get the best outcome in a mathematical model whose requirements are shown by a linear relationship. Here on mantras like we'll study, whenever if we get profit or gain, we'll do maximize. If it is not, we will try to minimize. Actually, special case of mathematical optimization. In that, linear means relationship are represented by straight line. Straight line format in lower classes we studied. Equation of a straight line formula is y equal to mx plus c. In the same way we are going to describe. Here there are two variables are there. One is directly proportional or more which are directly proportional. Programming means optimal allocation of limited sources. Optimum allocation. Whichever the limited sources are there, we can use it maximum allocation. In fact, every organization faces the problem of allocating limited resources to different activities. Such type of problem arises when there are alternative ways of performing a number of activities. These products uses a common pool of resources whose availability is limited. Now the problem is to be carefully allocate these resources to different types of finished products in such a way total return may be maximum. Based on the past experiences and intuition will be decided as more. Definition of linear programming. This is a versatile technique for assigning a fixed amount of resources among competing factors in such a way that objective is optimized and other defined conditions are also satisfied. Linear programming problem is a mathematical technique for determining the optimal allocation of resources and obtaining a particular objective when there are alternative use of resources. The objective may be maximization or inversely profit maximization. That is meaning of minimization. Linear programming has been successfully applied to variety of problems of management such as production, advertising, transportation, refinery operation, investment analysis. Over the years, linear programming has been found useful not only in business and industries such as government, hospitals, libraries, etc. Actually, linear programming improves the quality of decisions. Objective function is a linear function of the decision variables representing the objective of the manager. Constraints are the linear equations or inequalities arising out of practical limitations. Decision variables are physical quantities whose values indicate the solution, that is greater than, less than, like that. Feasible solution. Feasible solution is a solution which satisfies all the constraints including non-negative presence in the problem. Feasible region is a collection of feasible solution. Multiple solutions. Solution which maximize or minimize the objective functions. Unbounded solution. The solution which objective is infinite. Objective function is infinite. Infeasible means no feasible solution at all. We are going to study in this one by one. What does that mean while solving the problems? Linear programming terminology. What are the terminology will be used? There are several purposes of serving building of your vocabulary about the concepts. Linear function. Linear function contain terms of each which is composed of only single continuous variable raised to the power of 1. That is called linear. Always should be power will be 1. Objective function. It is a linear function of the decision variables expressing the objective of the decision maker. The most difficult forms of objective functions are maximize or minimize of functions. Decision variable. These are the economic or physical quantities whose numerical values indicates the solution of the linear programming problem. These variables are under the control of the decision maker. Constraints. There should be a greater than or equal to or less than or equal to. The condition mathematical forms will be there. Non-negative, always it should be greater than or equal to 0 value. That is j equal to 1, 2, 3 up to n. The constraint is called non-negativity restriction. Sometimes variables are required to be non-positive or in fact unrestricted. Feasible solution. Any non-negative solution which satisfies all the constraints is known as feasible solution. Optimal solution. The solution where the objective function is maximized or minimized. Both the way you can say it is called as optimal solution. General form of linear programming problem. Look at that. There are different ways to write a general linear programming problem. This is one of the way. Objective functions will be maximum or minimum. So z equal to c1 x1 plus c2 x2 plus c3 x3 etc. cn xn. xn x1 x2 x3 etc. xn are called the decision variables. c1 and c2 or c3 etc. cn is called as cost of the decision variable. Subject to the constraints. It is in the form of equations or inequalities. a11 x1, a12 x2, a13 x3 etc. like that. am1 m1 x1 plus am2 x2, am3 x3 etc. amn xn. Here particularly we need to be mentioned all the decision variables are greater than or equal to 0. Here how many variables are there? Based on that many variables we need to write compulsorily in the last of the general format. We have to write greater than or equal to 0. Here written x1, x2, etc. xn greater than or equal to 0. So in summation notation, LPP can be written as the form, short form will be written, and then here will be written constraints and non-negative. Previous slides what I explained, the short format will be written here, where Ci's or AB's are constant, Xij's are decision variables. Expression means that constraint that makes one of the three possible, less than or equal to or greater than or equal to. The expression xj greater than or equal to means must be non-negative. Xj's must be non-negative, that is greater than or equal to 0. 0 or positive values. Formulation of linear programming problem. The construction of that, the following formulas format will be followed. Identify the variables to be determined and then express the some algebraic symbols. Second one, look at the various constraints or restrictions present in the problem and express these linear equations or inequality, which are some linear functions of the variables. Last one is determine the objective function, that is maximization or minimization, and express as it is in the linear function of the decision variable involved in the phenomenon. Advantages or assumption we need to make it. There are a number of restriction or constraints expressible in quantitative terms, that is called numerical terms. Parameters are subject to variation in magnitude. Third one is the relationship expressed by constraints and the objective functions are linear because power is 1 should be there. The objective function is to be optimized with respect to variables involved in the phenomenon. The fundamental characteristics in all such cases is to find some optimum strategies under certain known specifications. Limitations of linear programming. The assumption that all relations are linear may not hold good in many real situations. Example, production cost may not be a linear function of output. In linear programming, all coefficients and constraints are stated with certainty. And then the solution many times is rounding off. When the number of variables or constraints involved in the phenomenon are quite large, when it may become necessary to use computers. These are the limitations of linear programming. Linear programming model formulation. In fact, the most difficult problem in the application of management science is formulation. Therefore, it is important to consider linear programming model. What are the things? Model formulation is a process of transforming a real-world decision problem into operation research model. What is the real-world problem that should be converted into operational research model? In the sections that follow, we give several repetitions examples. You can acquire some experience. Here is the sum of the problem which is given here. Universal Corporation manufactures two products, P1 and P2. The profit per unit of the two products is rupees 50, rupees 60 respectively. Both the products require processing in 3 machines. The following table indicates the available machines hours for week. So given information we do it. Here how many cost will be given to cost. How many products? P1 and P2 product. That is called objective function we need to be considered. Machine available time, that is called constraints. Look at that. This problem we are going to make as formulation of LPP. Look at here. Let x1 and x2 be the amounts of manufactured because two different products at the same time, two different amount will be given. Profit is given, so we'll get a maximization. Maximize the profit always. Suppose if this is the loss, then we can say minimize the loss. So maximum is that two products will be taken, 50x1 plus 60x2 because of the profit oriented products we consider as validation variables x1, x2. So we are taken as, since one unit product P1 requires 2 hours of processing in machine 1, while the corresponding requirement of P2 is 1 hour, the first constraint can be, previous slides will be explained the same way, 2x1 plus x2 available time is 300. Similarly, we can constrain other two machines 2 and 3 in that form. So all will be less than or equal to, within the available time they should use. They should not go for the apart from that time. So that's why we are using less than or equal to 1. This is the way we need to be convert into inequalities. Then we can write in the form of standard form. Here there cannot be any negative productions, so we need to use, I said earlier also, this is the one x1 and x2, or the decision variables are taken, that should be always greater than or equal to 0. The problem can be written in the form of maximum z equal to 50x1 plus 60x2 subject to 2x1 plus x2 less than or equal to 300. 3x1 plus 4x2 less than or equal to 509. 4x1 plus 7x2 less than or equal to 812. Don't forget, decision variables always greater than or equal to 0. What are the variables are involved here? We need to write x1 greater than or equal to 0, x2 greater than or equal to 0. Then we can take another problem. Here, Deep oil refinery we are taken. Here also profit only. Profit is considered. So this one here also maximize the profit. So we need to write here available time, you see input and output both is there together. You can make and mix it and write. Look at here, we can write in this format. X1 and X2 is a number of production runs of process A and B respectively. So maximize the product. So we will be written maximize z equal to 400 x1 plus 500 x2. Then subject to, so 6x1, each one product A, B we are taken. So we will be used 6x1 plus 3x2 less than or equal to 300. 2x1 plus 6x2 less than or equal to 250. Their output will be greater than or equal to use. 6x1 plus 4x2 greater than or equal to 120. 8x1 plus 5x2 is greater than or equal to 100. So in this way we need to make it. So the condition should be applied and then will be followed. Although all the above mathematical formulation of linear programming problem and the answers are very highly simplified. The decision problem shown as the counterparts of actual companies. This is the way formulating of the program LPP. The given situation we need to consider. This is the way we can solve the problem. Thank you for watching my videos. Any clarification or any doubts is there, you can contact me and get clarified. Next video we are going to see how to solve this problem in graphical method. Thank you for your watching my video.